Alright, 7.2. Use the converse of the Pythagorean theorem. Okay, so hopefully you guys remember the Pythagorean theorem. C squared equals a squared plus b squared, or a squared plus b squared equals c squared, however you want to write it. This says the opposite of that. It says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Okay, so if this is true, then automatically you know it must be a right triangle. Okay? So, for example, if you are given this and you are told to tell whether the given triangle is a right triangle, you can check it using the Pythagorean theorem. So like for this one, once again I'm using c squared equals a squared plus b squared. My c is 3 root 13. I've got 6 squared and 9 squared. Okay, 3 squared is 9. Root 13 squared just removes the square root. Okay, 6 squared is 36, 9 squared is 81. 9 times 13, let's see here, 117. And if you add these two together, you get 117. It checks out, so the triangle is a right triangle. Okay, let's take a look at the second one. I've got 16, 24, and 29. 29 is the hypotenuse. 16 and 24 are the other two sides. 29 squared. You could use a calculator if you want. I just don't want to pull one out. 18 plus 8, that's 26. $841. 16 squared. $256. And 24 squared, let's see here. I believe that's 576. So 841, if you add these two together, I'll just do it over here. Already, you know, it's not going to be the same because this is 2. Oops, sorry, that's an 8. 832. 841 does not equal 832, so the triangle is not a right triangle. Alright? So, if the equation checks out, it's a right triangle. If it doesn't, it's not a right triangle. Okay, now, if the hypotenuse is smaller than the sum of the squares of the two sides, you have an acute triangle. If the hypotenuse, or the longest side, is bigger than the sum of the squares of the two sides, then it's an obtuse triangle. So, if you take a look over here, the hypotenuse is bigger than the sum of the squares of the two sides. So this would be an obtuse triangle. Okay? Alright, let's do an example. Can segments with lengths of 2.8 feet, 3.2 feet, and 4.2 feet form a triangle? If so, will the triangle be acute, right, or obtuse? Okay, so we're going to use the triangle inequality theorem to check that the segments can make a triangle. If you add these together, you get 6. 6 is bigger than 4.2. If you add these together, you get 7. 7 is bigger than 3.2. Add these together, 7.4. The reason we're doing this, the triangle inequality theorem states that the sum of any two sides of a triangle have to be bigger than the third side. So if I took this side, let me use a different color. If I took this side and added it to this side, it has to be bigger than the third side. Has to be, or else you don't have a triangle. If you have two sides that when put together they're smaller than the third side, no matter how I bend these two sides, they're never going to touch. They're just too short. The only way you can form a triangle is if any of the two sides create a segment bigger than the third side. Okay? That's the triangle inequality theorem. So what we're doing here is we're adding each pair of sides and making sure that the sum of those two sides is bigger than the third side. In this case, we have a triangle. So let's classify the triangle. Let's go back to blue. Alright, c squared, or c, is going to be the longest side, so we're going to use 4.2. So I got 4.2 squared. We don't know if it's equal, bigger than, or less than. A squared is, or a is 2.8, b is 3.2. I'm going to use a calculator for this one. Let's see here. 4.2 times 4.2. We've got 17.64. Okay. 2.8. 2.8 times 2.8. 7.84. And 3.2. 3.2 times 3.2. 10.24. So if I add these two together, I've got 17.64 and I've got 18.08. This is bigger. Okay? So c squared is less than a squared plus b squared. The sides form an acute triangle. Alright? Okay, let's go on to page 3. Alright. You are helping install a light pole in a parking lot. When the pole is positioned properly, it is perpendicular to the pavement. How can you check that the pole is perpendicular using a tape measure? Okay, to show that a line is perpendicular to a plane, you must show that the line is perpendicular to two lines in the plane. Okay, so think of the pole as a line and the pavement as a plane. Use a 3, 4, 5 right triangle and the converse of the Pythagorean theorem to show that the pole is perpendicular to different lines on the pavement. So, first mark 3 feet up the pole. Then mark on the pavement 4 feet from the pole. If this is a right triangle, this has to be 5 feet. So, we use the tape measure to check that the distance between the two marks is 5 feet. By the way, I didn't mention this, but the reason it has to be 5 feet is because 3, 4, 5 is a Pythagorean triple. So this has to be, if this is 3 and this is 4, the Pythagorean theorem states that this has to be 5 in order for it to be right triangle. Alright, the pole makes a right angle with a line on the pavement. Finally, repeat the procedure to show that the pole is perpendicular. I guess I could have just written my little perpendicular symbol to another line on the pavement. Alright. Methods for classifying a triangle by angles using its side lengths. Alright, this is just a review of the theorems we just learned. If the Pythagorean works, if c squared equals a squared plus b squared, you have a right triangle. If c squared is less than that, it's an acute triangle. C squared is greater, obtuse triangle. Okay, so this is just repeating everything we just learned on the previous couple pages. Alright. Okay, the last page, it looks like it's just a checkpoint, so you guys can do this. And that's all for today.